Hey guys, and welcome back. So I completely missed one step in this process, and what we need is we need to find the gradient, which is basically a vector that points from that location towards the nearest isosurface location, and then the gradient or the surface field gives us back the information about how far it is, how far that point is inside the SDF. And what we need to do, instead of plugging this in like that, we need to multiply it by the SDF, by the sign distance field. And this is going to give us a vector which we normalize, and then we multiply it by the sign distance field, and then we add that. And once we do, we get a perfect overlap. So now if we go back up and play through this, you will see that the points will always move away and outside the volume. And this is the kind of collision I want to implement inside the sim. So I'm going to copy all of this, and I'm going to connect this to the fourth input, and let's dive inside. And I'm going to create a VOP, pop. I'm going to use a volume sample. I'm going to sample the velocity from the surface field. And the other thing we could do is we can merge both of this, and now we can reference individual channels. So we have surface and gradient. Okay, so let's dive inside, and let's dive inside here, and we have the surface. I'm gonna use a volume sample vector, and I'm gonna sample my gradient. Fourth input, I'm gonna sample the grad, and the sample position is this. I'm gonna normalize and multiply this. Normalize, negate, because the orientation is pointing inward, we need it to push outward, and then multiply this by this. And I'm gonna take the current position and offset it. I'm not gonna change the velocity or anything. I'm gonna force the point position to respect this. Let's go up, and let's enable cooking. And now if we hit play, yep, we should see it working. Cool. So that's our rubber toy, and you can see the points are moving around it and respecting it, which is great. And that's what we're going to use to collide with the RBD system. I'm not going to use a bullet or anything like that. We're going to use the same SDF that I used inside the smoke sim to be the collision for the sparks. And this is very important because we want the sparks to respect the rocks. If the rock is moving, we want all of that to get transferred. Now, if you want to take this further and improve on this, we can take some of this information and, for example, compute the cross product, which will give us a vector that curls around the geometry. So let's do that. I'm going to compute that vector, and I'm going to add it as a force. I'm simply going to add a multiplier, so I can use this, I can tweak the force of this, and let's set it to 20 just to clearly see it. So once they get inside, they're going to have a massive force pushing them around the surface. Okay, you can see it. Once it gets close, it gets pushed very, very strongly, but it still respects that. So you can inherit some of the surface flow from the RBD sim and inject that into your sparks or particle sim, whatever you have. And then one last thing, we don't need to compute the gradient here. What we can do is we can rely on computing it on the fly in here. So we can use a volume gradient node, and this is going to take an SDF. We have to make sure that we're feeding it an SDF, so a surface, and we're going to tell it to compute the gradient. And if we hit play, we should see the same result. So this is going to save us some SOPs computation, but it's going to introduce it here. So it depends on whether you have that data or not available. And I'm going to lower this force to 2, and let's go back up. And let's visualize this with the colors and everything. And I'm gonna template the geometry to show you guys what is happening. And you can see it always wraps around it. It never goes inside the geometry. Okay, so that's our collision, and that's it for this video. We're gonna continue. So okay, so right now we have all this stuff happening, which is great, but we still want to improve upon the behavior of the sim. Right now, what I'm really looking forward to add is when the particle dies, I want, as they get closer to dying, I want them to become very, very turbulent. So we're going to create a mask based on life that allows us to isolate the particles at their end lifetime and then use that as a mask to add a very strong turbulence. We're also going to add the spinning effect so that when we copy a grid, or so if I put down this delete here just to get less points. So if we copy a grid at the moment, it's gonna it's gonna be the same because there is no orient attribute. So we need to set that up. Let's copy 2 points. And it's 0.1, 0.1. So you will see right now they have the normal orientation, but it's not ideal. We want them to flip, rotate, and as they get closer to dying, I want them to spin faster, or maybe have that change just over time. And I'm going to show you how to control all of this, and then it's up to you guys to continue exploring this path. And let's do that in the next video. Thank you guys for watching, and see you in a bit.